Hello and good evening to all. Welcome to another tutorial session. So I see Ayanar raised their hand. Yes, Ayanar. Oh, the hand is. Did someone have anything to say? Okay. So uh, before we start off today's tutorial session, any doubts regarding the previous sessions or previous content regarding the course? Anything that you want to ask me, get something clarified? Okay, in that on that note, if no one has anything to ask or say,
Hello.
people who have just joined, anything that you want to say regarding the course,
Yes, yes.
regarding the previous content on the course, any doubts you have?
Mohammed, am I audible?
Yes, Jagdish
Uh,
Kumar. Yes,
yeah. I have two questions regarding the answers provided in the assignment 2, where
assignment.
there is a comparison of drug A and B. In that particular difference is one sum is provided. Right now I am in mobile, though I am not seeing exact questions from my screen, but the
Okay,
difference of the I think low glucose level reductions,
okay,
where the comparison is provided and answer provided is uh, I think placebo, if I am not wrong, and drug A, or
okay,
either A and B. But the
okay,
answer, whatever the answer actually provided in the answer sheet,
okay,
is contradictory with my answers, because the reductions in the that particular glucose level, or that in diabetes, uh, here in this particular case, the provided value is a difference between two set.
okay,
So we don't know the actual value which provided in the reduction is in minus form or in positive form.
okay.
So both the answer as per me is correct, because there is a no clarity in the questions.
Yeah, I
And
think.
second,
Yeah.
second is I think TSS divided by degree of freedom. That's the answer actually. And last three digit we provided in the answers, but only two digit considered, and our true value is not considered in the answer, because we have written in the three digit. There is a
Oh,
3 points actually. A
okay.
three
I think
point of
that's a
that
software
particular answer.
glitch. That's a software glitch. Uh, I don't think you can just write to whatever forum you usually write to, or write to the course coordinator. I'm not a course coordinator, so I don't have rights to administer all these glitches. Uh,
But Mohammed, actually, this question was for the 3 point, and there is a no. Actually, multiple people have made such mistakes, is because in the questions there is a no any clear cut guideline in how many digits we need to provide our
yeah,
answer.
yeah, I agree. Is there any forum for redressal regarding this? I'm not sure. I see from my side of the course, I don't have access to all of these things. Uh, I think you need to raise it up with whatever platform that course feedback is on. Yeah, and also maybe just mail the course coordinator directly if you have been given an email or something like that. That would work
So,
best.
Arpit considered as a course coordinator.
Yes, yes, yes. But he's also a TA like me.
Okay.
Yeah, I don't think he'll also be able to help you with these things.
But actually, my suggestion is, if such a contradictory questions is there, then we should provide ABCD in answer.
Yeah,
So
yeah, no.
accordingly,
So
people
the
should
thing is,
write.
we don't. It's not in our hands to design the questions at all. It's
Okay, okay.
Yeah. So we don't have any sort of hand in this. But you have to. I think just mail the whoever whatever contact has been given you regarding the course.
Okay.
Yeah. So sorry, but the question in assignment two, you said there was something that some problem you had. Drug A and drug B. Uh, yes, lot of things have drug A and drug B. Oh, that is it that drug A is better than drug B or something like that?
Drug A or
Which question
Yeah.
was this? Okay, the last question. Two drugs A and B were tested on 10 and 12 subjects for lowering their blood urea, and yeah. So here you just need to do a t-test. Simple t-test, mu1 minus mu2 divided by you have to pull the standard deviations. You have been given the number of subjects also. So just a two sample t-test and that should give you the answer, which is that drug A is as good as drug B. I don't have not calculated this, but I'm assuming the answer is it's an option thing. Which one did you have a problem with? If you can tell me the exact question.
Mohammed, I am driving. I'll reach within a 5 to 10 minutes at
Okay,
my
okay,
home.
maybe we'll do
Then
it. We'll
I'll
discuss it
clarify
at the end of the
my
class.
questions.
Yeah, we'll have
Right? Yeah.
yeah. So sorry.
Give me a 10 minute. I'll reach there.
Yeah, yeah.
Okay.
We'll do it at the end of the class. So in today's class, it's just we'll just do one ANOVA, one example of ANOVA, and yeah, I think that's about it for today's class. So everyone has gone through the videos, no, for ANOVA. When do you use an ANOVA? When do you use a t-test? How is a t-test different from an ANOVA? Anyone?
When we
When we
have
want
three
to
variables,
compare,
Sorry, just one
yes,
please, one at a time. Yeah.
yes, when we want to compare two groups, we always go for t-test, and when we have more than two groups, we compare them with ANOVA.
Okay. Just a little correction in your statement. When you compare two groups, you don't always use a t-test. To use a t-test, you need your data needs to satisfy certain conditions. What are those?
Normal
Anyone?
distribution,
Normal distribution of what? Your response variables, right? Whatever you have
yes,
measured, they should have a normal distribution and their variances should be similar. The groups that you compare, they should be sort of similar. It's called homoscedasticity. Okay. But yeah, these are two assumptions. And yeah, sometimes your sample size also needs to be a little large. They can't be too small and things like that. But that's for another day. Okay, so ANOVA is yes, as you mentioned, used to compare the effect of when you have more than two or three groups. You need want to compare when you have more than two or three factors. You want to compare whether those factors are affecting your data and things like that. You use an ANOVA again. Your data should be normally distributed. Okay, for ANOVA, these are all parametric tests. For parametric tests, your data should have some structure. Okay. Now, here is a table where you've been given. So, what people have gone and measured out is some gingerol levels in certain plants. It's pepper plants, okay?
sir.
And yes.
Sir, screen visible नहीं
Oh, sorry. Okay, so sorry. Uh,
है.
okay. Wait. Still not happening. Okay, so yeah, so you have this data where people have gone and measured some gingerol level. This is some chemical that is found in pepper plants. They've gone out and measured this, and these are the values in some units. It's units is microgram per gram. Okay, and also what they've recorded is what variety of pepper it is. We have three different varieties: V1, V2, V3. Also, the kind of pesticide that was given to them, there are again three types: P1, P2, P3, and there are fertilizer and the fertilizer that was given to these individual plants. There were F1, there were three kinds again of fertilizer, F1, F2, and F3. So the broad idea is to identify which of these factors, fertilizer, pesticide, or variety, majorly affected the gingerol levels. Okay. To do that, you can use an ANOVA. Okay. Now, just like they've asked some certain values just to get you going. The first is what is the mean value for fertilizer treatment F1? You just have to take the mean of these three values because of F1, you have these F1 things, right? Three values here. You need, if you take the mean of 25, 55, and 45, you get the mean for this, which is around 42, I think, 41.66. Same again, what is the average yield for pesticide treatment P2? Look at P2, wherever P2 is, P2 there's 55, P2 there's 20, and P2 there's 50. So you take the mean of that, that again comes to something like 41.6. Okay. And then lastly, you need to take the average yield for ginger variety V3. So what are the V3 variety values? 25, 30, and 20. If you take the mean, you get something. I think it is. I just calculated this before. 25. Okay. Those are something that you needed to calculate. Last week we had some, yeah, we had the formula for total sum square. It was slightly long, is what I've heard. So then I went back and like looked up the book. And what I found was there's another formula to calculate total sums of squares, and that is this. You calculate the grand mean of the entire data set. That is the mean of all these data points. You get something. You now for each sample, that is each sample, you take xi minus the grand mean and square that. Okay. When you square that and you keep summing over, you sum all those squares, square of these differences, you get something known as a TSS. And in this case, that comes up to be around 2097, around 2100 if you sort of round off. Yeah. Someone's trying to join, I guess.
So, sir, we have to find the mean of all the 9 values.
For the grand mean, yeah. Yeah, for the grand mean, you need to find the sum of all values, and then for each data point, from each data point, you need to subtract that grand mean, okay, and square it. So you have like 9 values, right? So each value 45 minus whatever grand mean squared plus 55 minus grand mean squared, and so on and so forth. And you, when you do that, you get the TSS, total sum of squares. Okay. The next question is regarding what is the grand average, we did that. What is the total sum of squares, also we did that. Okay. Now, I'll ask you, so now let's do an ANOVA, okay. What the last question is, you have to do an ANOVA for that. Which factor is significant at 95% confidence limit? Basically, the question means which of the factors of these things, fertilizer, pesticide, or variety, which of these affects the gingerol levels, okay, under a 95% confidence limit. All you have to do is run an ANOVA. But in your case, you need to calculate. Okay, I've already calculated these things. So first, let us do this column by column. Now, first we need to calculate the degrees of freedom. Okay, what are the degrees of freedom for fertilizer? How many fertilizers do you have? 3. So how many do I need to minimally define so that I get the complete set? I need to define at least two fertilizers, right? So the degrees of freedom is 2. Pesticides, you have 3 pesticides. So the degrees of freedom of pesticide is again 2. You have 3 types of varieties. So the degrees of freedom is 2 again. Okay. And this error is basically what is your total degrees of freedom that you have? You have 9 data points. Your degrees of freedom in data points is 8. Okay. 8 minus the sum of fertilizer plus pesticide plus variety gives you the degrees of freedom of error, which is 2. Okay.
Sir,
So,
please,
yeah.
sir, please, for error degrees of freedom, can you please elaborate your answer?
Yeah, so how you can calculate degrees of freedom of error is, there's another way to do it, and that is you have the total number of degrees of freedom, that is 8 data points, right? That is your total degrees of freedom. 8 is your total degrees of freedom.
Okay,
From
sir.
that, you just subtract the degrees of freedom for fertilizer, pesticide, and variety. You'll get for error what the degrees of freedom are. Yeah, so it's 8 minus 6, right? 2 plus 2 plus 2, 6. So you get 2. Okay. Did everyone get this? Okay. Next is can you switch off your speaker? Sorry, microphone if you are not don't want to speak.
Please share the screen, madam.
Thanks. So the next is you need to calculate sum of squared. Now that is again we did a little bit of this in the last class, but here I've just mentioned values. How you have to do this is for fertilizer, you need to calculate. You know the so you need to calculate the mean. Let's go to the data set. Okay. Yeah. So for each fertilizer, you need to calculate the mean. So you have a mean for F1, then a mean of F2 and F3. To get the sum of squared for F1, you have to do 3 times because it's repeating 3 times. 3 into the mean of F1, whatever value you get, minus the grand mean squared. Okay, 3 into mean of F1 minus grand mean the whole squared. Okay, so you get it's, if I just write it, it's this. I'll just write it for you on your new slide for F1. Okay, for F1 you need to it's 3 into mean of F1 minus grand mean this power 2. Okay, only so this is how I would calculate it. F2 again the same thing, 3 into mean of F2. Okay, likewise for F1 and F2 and F3, and I sum all of these values that I get F1, F2, and F3 to get the sum of squared for the fertilizer. Okay, that is nothing but this value, this 16.67. Same thing I do for pesticides, P1, P2, P3. I add all of them, I get this. For variety, I add all the 3 things, I get this. And the error is, there's an easy way of calculating for error. You know the total sum of square, that is around 2100. You've already calculated it, right? You subtract you add for fertilizer, pesticide, and variety, you add what the sum of squared is and subtract it from the total sum of squared, and you will get this value. Yeah? It will come something
Sir,
closer. Yeah?
sir, for fertilizer, no, you had calculated sum of squares for F1, F2, F3
Yeah?
separately, no? After that, what do we do with that next? You have one value 16.67.
Yeah. So you have to sum all of them, F1, F2, and F3. If you
Add up all.
yeah. That is meaning of sum of square. The meaning of the sum of square.
Okay.
Okay. Same thing for P1, P2, P3, and variety V1, V2, V3. You get these 3 values, and if you subtract the sum of these 3 values from your total sum of square, you get for error. Okay. Now, what is mean sum of square? Nothing but divide this value by the degrees of freedom. Okay, for each of the factors. So it's 16.67 divided by 2, 116 divided by 2, 1850 divided by 2, and 116. So you get mean sum of squared. Okay. To calculate f values, all you have to do is divide for each factor. Okay, something happened. Okay. Yeah, it's come out correct now. Yeah, for each factor, you need to divide f value is nothing but mean of this sums of square minus error. Okay, so you get some values. Okay, you wait, something wrong has happened here. This has to this needs to be 1. Okay. So 8.33 divided by the mean of sum of squared error, that's 116.67, you get 0.14. For the next thing, it's the same, 58.3 divided by 58.33. For the next thing, it is 925 divided by 58.33. That's 15. So this f value is nothing but if I type it out, f is equal to mean of sums of square divided by mean of SSE error. Okay, that's it. So for each 8.3 divided by 58.33, 58 point, that's for fertilizer. For pesticide, it's 58.33 divided by 58.33, and so on. That's what it is. Okay. Now, once you have the f values, you just need to look up a table. For each degree of freedom, you have this f value, right? You have calculated, and for degree of freedom, we need to find the p value. Okay. So that's from tables. You can do that. You have the f value tables. You need to just specify the degrees of freedom and the f value, and you will get a p value. And we see that for variety, for fertilizer and pesticide, it's much greater than 0.05. For variety, it's 0.05, and it's not still significant under the 95% confidence interval. Yeah, but it's slightly high. It's called marginally significant. Okay. The actual answer, apparently, the answer to this is that your V is significant, variety is significant. It's in our case, it's actually marginally significant. It's not less than 0.05. Okay. So yeah, that is how you do an ANOVA. So basic things, just calculate your degrees of freedom correctly, calculate your sum of square correctly, and then you just have everything is there, then can then be derived. Sum of square is mean is just sum of square divided by the degrees of freedom for each of the factors, and f value is nothing but mean sum of square for that factor divided by the mean square for error. Okay, and once you get f values, you calculate for given your f value and your degree of freedom, you can get your p value from your table, and you just evaluate which is less than 0.05. That's your. You can have more than one factor, that is important. Also, you can do
Sir,
interactions between these factors. Yeah,
sir,
someone had
that
something.
sum of squares, under sum of square column, we
Yeah,
have error 116.67.
yeah.
How did we calculate that one?
So you just have to sum up whatever. So you sum these three values, okay, and you subtract the sum of these three values from your total sum of squared. That is 2097. That will give you sum of squared error. Remember, we did this in our very previous class. What is sums of squared? It is graphically to show you for each data point. It is this. For it's this, right? This is the total sum of squared. Sum of squared error is this thing. So if you fit a model, the distance from the model to the data point is sum of squared error, and sum of squared residual is this from the mean to the
Sir, there is
model.
some echo. I can't, means I think all of us can't hear properly because some echo is there.
Okay, that's maybe because I'm sitting in a very large room.
Or sir, if anyone is not muted themselves, can mute once.
Yeah, people who have not muted yourselves, can you mute if you don't have anything to say? Is it better now?
Yes, sir.
Yes,
Now
sir.
it is better
I
actually.
think people
Now
just
it's
had
better,
their
sir.
speakers on. So sorry. Sorry, their microphones on. But yeah, that was how you do the ANOVA. You just, yeah, do this table. Important thing is to figure out degrees of freedom. If you figure that out, this is just from formula. Even this is from formula. I do it intuitively. Once you have this, all these are derived from these two values. And then f values divide this divided by mean of sum of squared error. Find the f value, find for each, you have the f value and the degrees of freedom, find the p value for that. Yeah, you'll get it. Anything, any doubts regarding this?
Sir, for error point, actually I didn't get how you calculated the sum square and mean sum square for error actually.
For error, what I did was I added these three things and subtracted it from the total sum of squared, and I'll get this, something close to this. Did you get that?
And how about mean sum?
How about mean? Mean, I just like each value divided by the degrees of freedom is mean sum of squared. So 8.3, 16.6 and divided by 2 gives you this, 116.6 and divided by 2 gives you this, things like that. Yeah.
Okay, sir.
Okay, any doubts regarding this?
Hello?
Hello, yes.
Amir, how did you calculate p-value there, 0.875?
So you look up this table. So there are F tables, like we had T tables, there are F tables also. Uh,
Yes, yes.
so we have our F value, we have our degrees of freedom. Okay. Using that, you can calculate your P value. So let's check some F table. A lot of F tables out there.
Can we do it on Excel?
Yeah, I'll do it. So this, so okay. Now for alpha, this is for alpha 0.10. Okay, what we did was alpha 0.05, but what you have to do is alpha 0.10. So degrees of freedom is we have uh, for the first thing, it is 8 comma 2, because 8 is our total degrees of freedom. So F is calculated, you have 2 degrees of freedom, total degrees of freedom, and for that factor. So 8 comma 2, maybe I'll do it for alpha 0.05. Okay, we have that, yeah. So 8 comma 2, okay. So for that, there's an F value of 19.37, okay.
Hmm.
If now the value we have calculated is how much? 15.85. It's actually less than that. So you won't get the exact p value. You'll know that it's less than 0.05. Sorry, it's greater than 0.05.
No, no,
So
actually, we can use Excel software.
yeah, no, I thought you weren't allowed to use Excel software. The Excel, that's how I got from Excel.
This is for finding F critical.
Yeah, F critical, but the exact thing I think
When
F
we are
inverse.
calculating p-value,
Yeah.
p-value is different.
So 0.05. No, no. F value.
Yeah, F inverse, I think. F inverse,
F
yeah. No, F
inverse.
test, F test, yeah.
F test. No, not F test. That's okay. F test. No, I have to give my arrays. I know my F value. I need to find
F test, I think. F test.
F dist. Yeah.
That's what
So
professor.
that is how much? 15 point something. How much was that? 15.85. Okay. And 8 comma 2. Too few arguments. What is cumulative? I don't know the last bit. Just check this formula. This will give me the F distribution. I want just the F value.
No, no, we are finding the probability value, right?
Finding the probability, yeah.
F test will give the probability value, right? I think it's going to give the
Cumulative. I just need to figure out the syntax. Cumulative true, I need to write. Okay. So yeah, it's 0.93. So 1 minus 0.93 is give me something 0.61.
0.93, yeah? Or 93.
So you have to do 1 minus this. 1 is equal to 1 minus this. 0.0608. What have we got? 0.059. Yeah, it's some little calculation error. Yeah.
No, no, what is this 0.875? How did I got this one? I'm wondering.
0.875, same thing. You give the F value and you give, so if I give 0.142808 in this thing, okay, 1 minus 1 minus how much? 0 point, how much was it? 0.142. Yeah, it's giving me 0.982. Think Excel sort of does a problem.
No, no, actually, I think we have to use some other function, I think, in Excel.
Okay.
Sir,
I
how is degrees of freedom? How do you take, sir? I mean, for
degrees of freedom,
C-fertilizer.
one you have to take the total degrees of freedom. That
No,
is
no.
8.
For fertilizer,
Huh?
you are having 2 right here.
Yeah.
It is 3 fertilizers minus 1.
Yes.
Similarly, for pesticide variety and
Yes.
total degrees of freedom is how much?
8. N minus 1. So 9 is your number of data points minus 1, that's 8.
8. Okay. Oh, so error is 2.
Yeah.
Sir,
Yes?
what is the need of probability over here? The slide you are showing to us. What
Yeah.
is the need of the
So the
probability
probability will
calculation?
tell you how likely, so how significant your result is basically. That is what it's telling you. It is telling you if this
Isn't
was,
it isn't it appropriate with the F value we can say ki variety is the more significant because variety is the highest is the value, the
no,
more
no,
significant.
you need just F value alone will not tell it, because F
Okay.
value you need to give your degrees of freedom. Depending on that, your P value will change.
Sir, during exam, when
Yeah,
we are going to give exam in the mainstream or the
yeah,
final exam,
yeah.
and if the question comes like this, and I don't know from where we can have the F value table and T value table. How we are going to calculate in
You
that?
otherwise you have to use Excel or do this. You need tables. There is no other way to do this. So I'm assuming you'll either be allowed Excel or your tables.
Okay,
Mohammed,
so
in
they
the
are
last lecture,
Yeah.
with Arpit, we discussed in depth regarding these questions, and he clarified that only calculator, online scientific calculator will be provided.
Yeah, I
No other
think
things.
I don't know
Even
how to
Excel will not
calculate.
provide.
Yeah, so I don't know how to do calculate this p value using an online scientific calculator. I
Amir, if you use app inverse, you can get the p
Yeah,
value
yeah, but do you
directly.
know how to
And
do it on
I
scientific calculator?
no, sir.
I don't know either. I looked up tables, like online tables, and got this value, but let's see.
no such informations available in the scientific calculator
Yeah,
as
yeah,
we see in
yeah, yeah. So I don't
Excel.
know. I think then you'll
Only
have
in
to use
raw.
this Excel, or there's no absolutely no way, because these F values are calculated. It's a very complex function. You can't sit and calculate your P value from F value just like that. It's going from here to here is very difficult if you
Mohammed,
don't have the table.
is there any planning that how because assignment is different, all the information is available with us, but
Yeah.
during the exam we have a limited information. So
Maybe
which
the
type of
questions
questions
will be
we
designed in such a
generally
manner you
ask?
don't need, or they'll give you certain clues. So at least when we had our exams, again we didn't have a lot of these things, but they would give us the required information to solve the question.
Okay.
And regarding, sir, the p value,
Yeah.
now none of the variables are significant here.
At the 95% confidence interval.
Yeah, because it is not less than zero point 0.5,
Yes,
zero point zero
0.05.
0.05. Yeah. So all the null hypothesis is accepted here.
You actually, there's a very statistical view. You either fail to reject the null hypothesis or you reject the null hypothesis.
Right now, p value is very high, right?
Yeah,
That's
yeah.
right.
So it's actually here, no, it's sort of marginal. I mean, but yeah, you can't say under that strict condition that it's significant. But if somehow I change my definition to 90% confidence limit, then it becomes significant. So there's a whole new world of effect sizes and confidence intervals that you should consider while you're interpreting things like this. I urge you to go read up effect sizes. I'll just type it out here. How effect sizes, so statistics these days, they rely on all these things. It's just not your p-value. Effect sizes and confidence intervals. Okay, please read up as much as possible in these topics. Look for these things when you read science research papers. These two things. Okay, it's not part of your course, but these are very relevant these days. Also, yeah, just if AIC values, things like that. All these things. Just go read up on them. See how relevant these have become. Yeah. You just can't nowadays. If you just submit a paper with ANOVA and you have this, they will not take your results. You will have to specify a lot other things, especially something known as effect size and confidence interval. These two things are very important. Yeah.
Sir, F value right now, F
Yeah.
value is 8.33 by 5.58.33, right? Fertilizer by error. That's what
Fertilizer
I
by
get.
error. Yeah.
That's why I get 0.1428, right?
Yes.
So 925 by 58.33 is 15.85. That's how
Yes.
I can
Yes.
calculate it, right?
Yes.
Okay.
Sir, how would we all are to be very specific for which p value table we are going to have our correspondence answers?
Sorry? So I don't think in the question they asked you whether you have to get your p-values exact. Actually, the question never said that. They just asked us which of these is significant. And for that, you just have to look up, as we did, for a t-table, if you look up, okay, 8 degrees, 8 comma 2 degrees of freedom, what is it? At 0.05, it is 19.38. Since ours is lesser than that, it's not significant. Sorry,
Sir,
19.3.
sir, it is 19.37.
Yeah. So that's a critical F critical. R value has to be greater than that for that thing to be significant. It's not. So it's not significant. It's slightly insignificant. The question never asked me to calculate uh, p value exactly. It just asked me to say whether which of these were significant or not. Actually, none of these are in the given.
Sir, just before the alpha is equals to 0.05, you had just opened one more table before 5 or 3
Yeah, that was
minutes before.
0.10.
So how would we know which table is correct to
Because
use it actually?
the question asked you at the 95% confidence interval, which means you need to look for 0.05. See?
Okay, sir. Okay.
Yeah?
Okay, sir. Okay.
Yeah.
I think for that we need to read confidence what you have written over there कि confidence करके कुछ
Confidence,
topic है
yeah,
वो
I
आपको.
mean, these are extra things. These are not part of your course yet. We did something
हाँ
on
sir.
confidence intervals, but how they are used in papers, confidence interval and effect size. Effect size
Yes sir.
basically tells you how much how much of an effect a factor is having and is it relevant at all.
Okay
So
sir.
read
Okay.
up on effect sizes. For example, if I go and measure the effect of some diet on height, and the diet is significant, it's giving me a value less than 0.005, but the average increase in height is only like 0.01 centimeter. So would you say that's actually useful, that diet? I wouldn't think so. So that effect size
Okay.
gives you some measure of that. Is what your effect you're saying, is it useful? Is it meaningful? Okay.
Okay sir.
Sir, can you just demonstrate how this ANOVA table is
Yeah.
given in the exercise, how it is used in software?
Oh, okay. Software, I don't know. I use R. Okay.
Yeah, yeah, R only. R also I am using,
Okay.
but
I
how to
just
feed this?
did it on R. I'll do it again.
How to feed these values in R? Okay, tell me.
Okay. So if I open R Studio, I mean, it's not part of your course. Okay. People who want to leave can leave. You can do it in any software. R is very good because it has all inbuilt stuff.
Yes, yes.
But otherwise, you can do it on anything. You can do it on Excel also if you have less data. It becomes hard on Excel when you have large amount of data. So I already read. So just 4 lines of code. You don't need this. You can just, this is just setting my
Can
working
you
directory. I
zoom
import
it,
this
sir?
data. So
Can you
what I've
zoom it,
done
sir?
is,
Can you zoom it?
can I zoom it? I don't know, yeah, how to do that.
Yeah, their
Zoom,
view
okay,
and
control
zoom in.
plus
Yeah,
plus.
yeah, control plus.
Okay. So I just imported my data. So my file that is week 4, it's a CSV file. It's like on this Excel that I can save it as a comma separated file. Okay. And what I've done is I've just written all that data
We
as
have
it
not
is.
received that file, sir. Have we posted that week4.csv?
Huh?
That week4.csv file is not there, I think, in the question.
It's not there. I made it. I just copied whatever was there in the
Okay,
question.
okay.
Yeah, I did it by hand. I made a week 4 CSV. Obviously, you have to get your data in some format. That is just an image for me. So yeah, this is my data. I import my data and then I just run this statement. Model is, it's a variable that stores the information from this whatever ANOVA. You can specify the ANOVA like this, ginger all as a fact, and these are the factors. I've just added them. I'm not testing for any interaction. Just the factors as they are without any interaction. And this is my data. That is this whatever I've imported. So if I run all of this and I do an ANOVA of my model, it just gives me this table very quickly. I don't have to calculate anything. It's all done. Okay.
What is that ginger oil, sir?
Huh?
What is that ginger oven?
Ginger all is my response variable, number of amount of ginger all present. That's my data. If you see, this is the response variable I'm measuring, ginger all levels.
Okay.
Okay, but this is, yeah, you don't have to do this. That part of, uh,
Just give ANOVA. Okay.
yeah, yeah. I mean, there are a lot of things you can do on R. You can, yeah, R is very good to do any kind of statistics, most kind of statistics, not all. Okay, if there are no more questions, are there any questions? Oops, sorry,
I think by
sorry,
he is now.
I just got locked out. Yeah, I'm back.
Yeah. Amir, can you please put some emphasis on the significance word with respect to 95% confidence interval and how to interpret the result with respect to p-value?
So traditionally, if anything was below point, so there are different criteria in different fields. For example, in medicine, many things have to have a significant value of less than 0.01. In ecology, 0.05 is okay and things like that. Okay, why medicine is low? Because if your drug is a little bit harmful also or not working, it can cause a huge effect on human health. That's why the criteria is stringent. Now, if you don't get a value less than say if at 95% confidence interval, if I'm testing and I get my p-value as 0.06, now would you call that as insignificant or is it a negative result? It will depend on your size of confidence intervals. Are they actually different or not? Okay. Also, it will on your effect size. For example, if I have a large effect size, okay, but my result is not very significant. By this, what I mean is, okay, let's take the example of diet. I'm giving some sort of protein diet to certain people, two groups, and when I compare it to the control group, my height difference in my diet in group treatment group is say they are 10 centimeters taller, okay, but this result is not significant. It's like 0.06. Now, would you discard this result saying, okay, that drug, that diet has no value? No, right? Because your effect size is so large. It has a 10 centimeters, giving that much a height advantage. So you have to state that, okay, even though it's coming out insignificant, these are my effect sizes, and that's why this is important. On the other hand, if I have a diet that gives me just, it is significant, but this gives me a height advantage of 0.01 centimeters. Would you make that diet important? Would you prescribe it to, say, people who go to schools and colleges? No, right? Because it's not at all helping. 0.01 centimeters is nothing actually. So that's why effect sizes plays a role in determining the results of your, in interpreting your results of your research. Even confidence intervals. Sometimes they might, you might get a significant result, but your confidence intervals are overlapping to some extent. So it's not only confidence interval, you have to take all these in mind, your p-value, your confidence interval, and your effect size. Please read up on this. There are a lot of papers on this, how to use this and what is the importance of this. Yeah, did I answer your question? To some extent, it's a very, actually very hot topic. It's been going on for the last 10, 15 years and will keep going on until we find better ways of doing statistics. P-value is not the ultimate answer to your whatever statistical test you do. Yeah. Okay. Did
So
anyone have
during
anything else to say?
three-way ANOVA, three-factor ANOVA,
Yeah.
now there are many interaction effects here,
Yeah.
right? So it is whenever we consider three-way ANOVA, it is necessary that we have to take only two variables at a time.
No, no, you can do so. I can. So the thing is, when you do interactions, you need to have large data. Okay, your other degrees of freedom should be less than total degrees of freedom. Okay, for example, with 10 data points, I can't have 10 factors. How can I put factors? So if I do this R thing that I was doing, I can put all those interactions. Okay, I'll show you. But yeah, interactions is hard to interpret and hard to do if you have less data. You need to have a lot of data to do interaction, at least 10 times more data than the number of factors. For example, if I have three here, three factors, I need to have at least 30 data points. Otherwise, it's not easy to do these things. At least 30, yeah? These are thumb rules. How can I put interaction? I do fertilizer, I know many things.
So professor explains that.
Your screen,
Hello.
screen is not visible, Amir.
Oh, okay, okay. See, I can put all these. So this is one interaction, fertilizer, pesticide. I can do pesticide into variety, variety into fertilizer. Then I can do an additional three factor thing. Like I can put all the three factors and their interaction. Let's see what that gives me. It will give you something that looks very odd. Like it's not advisable to do this. It won't. I mean, there are other ways. Pesticide and variety. Okay. Then variety and fertilizer. And then I can put all the three together. So unless you have a reason to believe there are, so always for good hypothesis, your hypotheses are the base to making all your statistical inferences. Okay, you just can't do any kind of statistics once you have your data. Okay, you can't like always when you do your data, you need to sorry, you need to actually put in factors that you think are meaningful. Showing some error. Must be your data frame. Yeah, so this is my thing. It's not even calculating because see, is giving all NaN values. It's not viable. I don't have enough data to do these kind of things. You need to have a lot of data and just don't measure any interaction. Be sure that okay, this when you start off your question, you should say okay, these interaction might be affecting my results, and then do the statistical test. Okay. Otherwise, you can do a lot of things with the statistics, and you can get any result which might not actually be true. There are a lot of ways in which. So there is a book called Lies with Statistics. It does not cover everything, but it's a good book to show you how people can lie with statistics. You can just play around with your computer and make something look very different, which is not really true. Okay. Always, always be clear with your hypothesis, your question you're asking, and then do your statistics. Only put in factors that you think may be important. Then see if they are important. Just don't put any factor in and look at their importance.
I have a doubt, sir.
Yeah.
Sir, professor explains in the lecture that
Yeah.
for a three-way factor, three-way ANOVA,
Yeah.
initially calculates degrees of freedom for A, B, C,
Hmm.
and it takes interaction for AB, AC, BC
Hmm.
for 1 degree of freedom.
Hmm.
Totally, it comes to 7 degrees of freedom.
Hmm.
So he calculates the F critical value at 95% confidence interval.
Hmm.
He doesn't get any. I mean, we don't get any significant factor there.
Hmm.
So all the F values will be less than F critical.
Hmm. Greater than, not less than, greater than.
No, no. In the three-way, what professor has done,
Yeah, yeah, it will be greater than. Oh, sorry, it will be
yeah,
less
F
than. Sorry, yeah, yeah, less than, yeah. For
161
non-significant, yes.
161.45 he
Yes,
gets
yes,
for
yes, less than, yes.
for all the factors A, B, C,
Hmm.
and interaction A, B, A, C, and B, C.
Hmm.
Yeah, none of the values will be significant.
Hmm.
Then he combines all these interaction terms to error.
Hmm.
Then he gets 4 degrees of freedom there,
Okay.
and then he recalculates the F values.
Okay.
And at again 95% confidence interval, degrees of freedom 1 and 4, the value B will be significant.
So what has he done? He is ready. He what did he remove?
No, no, why has see first he took A, B, C values, right?
Yeah.
And then
And
he
then
interact.
and then their interaction is does not get any significant.
Yeah,
Then what does he do?
then again he did not get any interaction. He did
Yeah.
not get any significant values.
Yeah.
So he increased the degrees of freedom for error.
And you have to then take out something from somewhere. You can't have interactions.
He removed the interaction variables. He removed
Yes.
interaction variables and
Yes.
added the degrees of freedom to error,
Yes.
right?
Yeah.
So there, once he did that, he got the value variable B as significant.
Yes.
But once without with only error 1 degrees of freedom, we did not get any
Yes. So that's why
significant.
that's what I was trying to say here. So
So
I've
what is
done
the
something
what is the
similar.
inference here? What is the inference? Why we need to add up to all these error terms?
So I mean that is just the calculation. So when I just did these three factors, all the other degrees of freedom went into my error. Okay. But when I started putting all these interactions, those degrees of freedom started coming into my from the error to the whatever terms as interaction terms. See here it says 2. Residuals became 0. And because
Yes.
of that, it's not able to calculate, okay, mean error, whatever. But what
Yeah.
he's trying to do is he's removed the interaction and then did the ANOVA again.
Yeah.
That's what
Yeah.
we have done. So if I remove
Yes.
this, so if I remove my interactions, and then do it, I get something. Okay, I can put interactions. Okay, that will take away some degrees of freedom from my error. Those are just ways
Interaction.
of calculating. You can put interactions, you can remove interactions and things like that. You need to be sure why you're putting in interactions. That's what you can get different results by having different kinds of factors here. I can just put two, I don't need to put even variety. I can just put these two and I can do an ANOVA. So it's not checking for effect of variety at all, just pesticide and thing. It's not giving me anything. I can just put one. I can just put fertilizer. It will just give me effect of fertilizer. Okay. The number
Yes.
or the kind of factors you put in need to be aligned with your hypothesis. What are you testing? Are you testing for interaction? Then put interactions. Are you testing only for some factors? Then put some factors. Or both? Then put both. But be sure of what factors you want to put in and do your ANOVA
Now,
accordingly.
what is the need for removing interaction? Is the hypothesis says like that?
Yeah, so
Based,
so suppose I
based
was
based on
thinking,
hypothesis.
yeah, yeah, it should be ingrained in your hypothesis. For example, if I think, okay, if I'm growing plants, okay, and I check the effect of say fertilizer and temperature, okay, I give certain fertilizers and I place some plants in warm versus something in cold. Okay. Now it could so happen that okay, fertilizer is affecting the temperature is affecting the action of fertilizer itself in some manner. Okay, those two are acting in some conjunction, and it's giving me a different value. Okay, then I would put an interaction of temperature and fertilizer.
Is
I
that
should have some inkling beforehand
no,
to
is it
think that
trial and
okay,
error?
then huh?
Is it trial and error that we need to do?
Not always. So this is actually a very gray area. I'm not an expert to comment on this. Some people do just trial and error, but it's wrong. You need to have some reason to do these interactions because okay, if I'm doing this trial and error, okay, just imagine, and I find this interaction is significant. Was it really? Did you design your experiment the way to detect that interaction? Your experiment, when you design your experiments, you should beforehand design your experiment such that okay, if I'm testing for this interaction, I should have enough data. My data should be my experiment should be designed in such a way that I can test this interaction. If I have very few data points, it can give me some significance, okay, but it might not be actually true, is what I'm trying to say. So when you design your hypothesis and you design your experiment, be sure, okay, when I'm doing my statistics, I'm going to check for interaction. And to do that, I'll have my sample sizes accordingly. I'll have larger sample sizes. I don't do it post hoc just to see by trial and error. If you're doing by trial and error and you get some significance, it might actually be wrong. Not always wrong, but might be wrong. Your
Now,
the power of your test
professor has
decreases. Your
the
power,
professor
it's
has
called power of your test, it decreases.
now professor has removed that all these interaction effects and he has made error degrees of freedom more.
Yeah, that it will happen naturally, no? They will go to the error.
Now, what is the need for that? I'm not getting it. Why
It's
we
just
need?
math, no? So if you so here all your degrees of freedom should add up to your total degrees of freedom. Okay?
Yeah,
So if you remove your interaction factors, those degrees of freedom have to go somewhere else. They will go into the error.
that means there is no interaction between A and B. That's what
He's not testing for it in his model
you're not testing
for
interaction effect.
interactions. He's
But
just
is it
sorry.
a false positive?
No, 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 not false positive. He's just not testing for it. He just removed the interaction and is testing for A, B, and C. If you thought beforehand interaction was helpful, you would have put it in the model. For
Now, before
example, if I thought fertilizer interacted with variety, I put it in my model. I run it.
but I didn't get any significant factor when I did with interactions.
Yeah, then
But when
okay, you
we
remove it. Maybe just the factors themselves are important.
factors and
The factors, just whatever two, three factors that you're assessing without interaction, those itself are enough to explain the model. Explain your ANOVA.
now whether with interaction or without interaction.
That depends on your hypothesis.
Hypothesis.
Yes.
Okay.
That depends on
Because
your question, what you're trying to answer. At the end, I'll tell you something. Statistics is just a tool. It has to explain your data. What
that's it.
observation you see. You
Yes, yes.
just can't use statistics to explain your observation. It is just a small part of your observation. You have to make meaningful sense. If you think interactions were significant, you should be able to explain why these interactions are significant. If
No,
you
no.
can't,
Statistic.
then the statistics
Any
will.
statistic. Any statistic for that matter will give approximation, right? It
Yes,
will not be true value. It is not
yeah,
going to be true.
It's never to give you a true value. Statistics, we do statistics to get at the true value, get at true causals, true
Yeah,
correlations.
approximation I can get. That's all.
Yeah, I mean statistics is just a tool. Please keep in mind that it's a human way of trying to explain what nature is doing, trying to understand what nature is doing. It's not foolproof. It has its flaws. ANOVA has its flaws. Your p-value has their flaws. Your all these things have flaws. Please read these books, Lies with Statistics. There are a lot of books on philosophy of statistics. Yeah, please do
No, we are
that.
just approximating whether it is pertaining to some area. That's all.
Yeah,
It's approximation.
yeah.
Not
All statistics is approximation. Why? That's why we calculate standard deviation. No? That's why. Yeah. Okay. I think that is something that takes another actually 6 months or more. The more you work with data, the more you realize how statistics can fail you. Okay, it can both enable and fail you. You have to use it wisely. It's a very tool with a double-edged sword, I would say. You can cut both ways. Okay. Okay, that's it for today's session. And if there are no
Amir,
more, sorry.
Jagdish here.
Yes.
Can you please explain the answer of the assignment 3 first question?
Assignment three, first question.
Yes, sir. We are having the same problem.
Oh, I think something like that similar. Even my answer was not matching.
Sir,
Like,
you said at that time ki both are equals, but the answer we got is new drug is better in that
no.
answer sheet.
Okay.
CV in the presentation or the understanding or learning sessions, they were using the older assignment,
Yeah, yeah.
not
I was
an
using the older
current.
assignment, not the new one. Yeah.
Yeah, so the difference will be there always. The conceptually they were giving the answer, but
So tell me,
now
week three, which
week
question?
3, first question.
First question. Oh, I don't
Yeah,
know. I have to calculate this. We are testing the effect of a new drug. The difference in weight are okay. Let's do a t twist. I'll do it quickly. Okay.
yeah. T test is failing. This is a one way ANOVA.
Yeah, one way
That's why
ANOVA. Yeah, one way ANOVA and t tests
one
are
way
the same.
ANOVA and the result is not passing. So how we will interpret this result?
So it's giving you a value greater than 0.05.
Yeah,
Then you will say that both are.
sorry, this is so t value are getting less than the critical value.
yeah.
So here,
Okay, then it should be both are equal. I think the simplest.
No, both are
can,
is not equal.
no, it cannot judge.
But the answer is new drug is better.
So if your p-value is greater than 0.05, then you will have to fail to reject your null hypothesis, which both are equal. So this is correct. I don't know. Yeah, new drug is better is not correct.
So
Both are equal.
Sir,
No, no.
actually,
See here, the p value is less than the
less
t
than, less
critical.
than.
It's less than
No, no.
0.05.
T calculated is 3.55
Yeah.
and T tabulated is 2.015.
Then it's significant.
So obvious.
No,
Ah,
no, 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 no. T calculated is 2.34, and at 5 degrees of freedom, T critical is 2.571.
Okay. Let's. I just do it for my sake. What
You
are the
can
values?
just do it in
I
ourselves.
did.
This is with
We
paired
did it.
t test. Paired t test.
No, no, no. You can do one sample t-test. Why paired? It's not paired.
One sample T test.
No, no. Yeah, one sample t test with difference with on the same subject.
Ah,
It's just yeah. You have to just calculate it whether it's different from zero or not. Okay.
This, the formula is d bar minus 0 by error, standard error.
no. Form. Okay. T is equal to D bar into square root of n divided by standard deviation. Where
No,
standard deviation, what we have got is 2.47. So D bar is 3.6 into 2.44 divided by 2.47. That is 3.55.
Okay. I've not done the math. I can't do it so quickly, but I just do a t test in R. Okay, 2 minus 3, 6, 8, 5, 4.
You can plug in the values in R and check it, sir.
2 minus 3, 6, 8, 5, 4. Okay. 2 minus 3, 6, 8, 5, 4. Okay.
Sorry, is it this one you have to do with
So the t value is 2.34.
Yeah, that's very simple.
Degree, yeah. So it's 0.06. So both are equal. So that's
How?
the answer. So yeah, I think you just write to the people, write to the course coordinator. If you think your marks are both are equal.
So this has to be done with one sample t test with difference.
One sample t test. That's